Imagine that we could really have a time machine that would show us what happened in the early universe, a machine that would become more powerful and give us progressively clearer pictures even as it aged. Imagine that the machine could detect worlds beyond our solar system, help map invisible dark matter, and characterize the expansion of the universe. It may come as a surprise, but this time machine does exist and is silently floating above us. Familiar enough to many to be taken for granted, the NASA ESA Hubble Space Telescope celebrates 2 astonishing decades in orbit on the 24th of April.
This is the Hubblecast, news and images from the NASA ESA Hubble Space Telescope. Travelling through time and space with our host, Dr. J, aka Dr. Joe Liska.
Wow, this thing travels over 28,000 kilometers per hour, 930,000 observations, 570,000 images of 30,000 celestial objects. 20 years, 2 decades and 110,000 trips around our planet.
Dr. J, 30 seconds to showtime.
Okay. After 2 decades of service to the scientific community and the public worldwide, tonight we are recognizing the achievements of what is arguably the most renowned and beloved space observatory in history. Welcome to the show. Now maybe you know it for its awe-inspiring images, or maybe you know it for its fundamental scientific discoveries, but chances are you do know it. Tonight we honor the Hubble Space Telescope with the Cosmic Lifetime Achievement Award.
It is not just about pretty pictures. Even though Hubble is famous for some of the most intriguing and coincidentally artistic images in the universe, astronomers, professional and amateur alike, have been translating the magnificent colors and poetic swirls of these images into hard-edged science. 20 years of observations have produced more than 45 terabytes of data, enough information to fill nearly 5,800 DVDs. Each month, the orbiting observatory generates more than 360 gigabytes of data, which could fill the storage space of an average home computer.
It is a real honor to be able to celebrate my dear friend Hubble. Tonight, we pay tribute to your venerable achievements and we look forward to the work that lies ahead of you. We will look at some of your most outstanding accomplishments and your most loved images from the past 20 years. One of your most recent achievements takes us back to the early days of the universe.
Scientists and space enthusiasts worldwide were wowed by the deepest pictures of our universe captured by Hubble. The first Hubble Deep Field was taken in 1995 and opened a whole new field of research. Hubble has since repeated the success, and the latest Hubble Ultra Deep Field image lets us see back in time 13 billion years, just 600 million to 800 million years after the Big Bang. This was one of the first and most spectacular datasets taken with Hubble's brand new Wide Field Camera 3. By studying galaxies at different epochs, astronomers can see how galaxies change over time.
A staple of science fiction films for decades, black holes are among the universe's most elusive and intriguing enigmas. Their existence was confirmed by Hubble in 1994, when Hubble's high resolution made it possible to see the effects of a black hole's gravitational attraction on its surroundings.
Hubble has also proved that black holes are most likely present at the centers of all galaxies. After this discovery, the orbiting observatory then began further examination of the relationship between supermassive black holes and their home galaxies, and found that a galaxy's bulge and the mass of its black hole are closely interconnected.
Hubble could also be honored with a Congeniality Award for getting to know our neighbors in the solar system. Hubble has imaged most of the planets and has the advantage of being able to carry out long-term studies from its vantage point 600 kilometers above the Earth. Have you ever been lucky enough to see the enchanting northern or southern lights? Well, Hubble has captured the alluring aurorae that light up the poles of the gas giants Jupiter and Saturn. And it has caught glimpses of comet impacts on Jupiter. Aside from the planets, Hubble has also studied asteroids, like the 500-kilometer sized Vesta. The resulting map of its surface shows a strange world with a gigantic impact crater and possibly even ancient lava flows.
But what is happening beyond our immediate cosmic neighborhood? This is a topic that fascinates many of us, and Hubble has not only helped to detect worlds outside the confines of the solar system, but it can also help to characterize them.
In November 2001, Hubble made the first direct detection of the atmosphere of a planet orbiting another star. In this case, it was the Sun-like star HD 209458, located about 150 light-years away in the constellation of Pegasus. Knowing the makeup of a planet's atmosphere allows scientists to determine whether life as we know it could conceivably exist on the alien world. In 2008, Hubble made the first visible light image of an extrasolar planet. It's in orbit around the bright southern star Fomalhaut, which is about 25 light-years away in the constellation of Pisces Australis. The star is surrounded by an immense debris disk, measuring over 35 billion kilometers across. The planet is orbiting about 3 billion kilometers inside the disk's sharp inner edge, which is about 10 times the distance between Saturn and the Sun.
By measuring bright stars that vary predictably, known as Cepheids, Hubble has been able to use these stars as distance markers, laying a firm foundation for subsequent measurements that led to the discovery of the accelerating universe and a more precise determination of its age.
Astronomers have used Hubble to observe Cepheids and to pin down their distances much more accurately. These results were used as a stepping stone to measure the distances to supernovae, which in turn told us about the scale of the universe. As a result, today we know the age of the universe with much more precision than before Hubble. It is about 13.7 billion years. In the 1920s, Hubble's namesake, the astronomer Edwin Hubble, discovered that the universe was expanding. The observatory that bears his name helped to determine the rate of this expansion and to show that in fact this expansion was accelerating. This was the smoking gun that pointed to the existence of the elusive dark energy.
When we look up at the night sky, it is easy to believe that space is just a giant void with some twinkling stars and a few recognizable planets. However, we must remember that there are structures and matter that we cannot see. Hubble is helping to define in 3 dimensions the distribution of ghostly and invisible dark matter in the universe.
Studies completed in 2007 and earlier this year gave astronomers a clearer idea of the structures that lie between galaxies. Now, these structures do not contain any stars, and they're made up mostly of dark matter, which makes them somewhat difficult to identify. By analyzing the Cosmos survey, which is the largest survey ever undertaken with Hubble, international teams of astronomers were able to obtain one of the most important results in cosmology, a 3-dimensional map which gave us a first and unique look at the web-like large-scale distribution of dark matter in the universe. This landmark result accurately confirmed our theory of structure formation.
Hubble has allowed for many comprehensive studies of the life and death of stars, the way stars develop, live their lives, and eventually die. Closely following the timeline of stars, we get a better idea of what is happening in our own galaxy and others.
Sensitive infrared instruments on board Hubble allow us to peer through clouds and columns of interstellar dust to witness the birth of stars. Many Hubble images feature blue hot stars at the early stages of their lives. At the other end of the stellar lifetime, Hubble lets us see remote supernovae and gamma-ray bursts, the final, dramatic explosions that signal the end of a star's life. And now, I'm proud to present Hubble's 20th anniversary image. Hubble captured the chaotic activity atop a 3 light-year-tall pillar of gas and dust in the Carina Nebula, located about 7,500 light-years away in the southern constellation of Carina. The pillar is being eaten away by the brilliant light from nearby stars, and it is also assaulted from within, as infant stars buried inside fire off jets that can be seen streaming away from the towering peaks. Nestled inside this dense mountain are fledgling stars. Long streamers of gas can be seen shooting in opposite directions from the pedestal at the top of the image. Another pair of jets is visible at another peak at the center of the image. These jets are an indicator for the birth of new stars. A jet like this is launched by a swirling disk around a star, and it is this disk that allows material to slowly accrete onto the surface of the star. What a fantastic image, and what a great way to celebrate this amazing observatory's capabilities. Thanks for the past 20 years, Hubble, and here's to many more. This is Dr. J, signing off for the Hubblecast, and wishing Hubble and all those who admire it a happy 20th anniversary.
Now that you've caught up with Hubble, make sure to get the latest from the ground too. The ESA Cast highlights the best of the European Southern Observatory and its powerful telescopes that observe from high in the Chilean Andes, at the Southern Hemisphere's best-known sites for astronomical observations.